Okay, I knew that would happen. I'm sorry about that. That was not my intention. But we'll pick up where I got cut off in the last one. If we take this point and reflect it perpendicularly over the y-axis, we know the x-coordinate is negative 1/2 because we're on the negative end of the x-axis, but the y-coordinate is the same as it is at pi over 3, which is positive root 3 over 2. And we continue reflecting those, the ones that are equivalent to 60 degrees or pi over 3, all the way around the unit circle. And we can continue to fill that in just based on those reflections because we know the x distance stays the same. We know the y distance stays the same over the x-axis. And so we have pi over 3, 2 pi over 3. When we reflect that over the x-axis, that brings us to 4 pi over 3. So we know the cosine of 4 pi over 3 is negative 1/2. The sine of 4 pi over 3, negative 3 pi over 2, because we're in quadrant 3, negative into the y-axis, negative into the x-axis. We reflect that perpendicularly back over the y-axis, and that brings us to 5 pi over 3, where the cosine is positive 1/2, and the sine of 5 pi over 3 is negative root 3 over 2. So between last lesson and this lesson, we have gotten all of the 3 angles in each quadrant that are not quadrantal angles. Now on the next lesson, we're going to pay attention to not only these angles, but we're also going to talk about the quadrantal angles and the other trig measures in addition to sine and cosine. But that gets us where we have a pretty good understanding of where all of the values that we're fixing to use on the unit circle come from. So we've gone completely around using those relationships in that 30, 60, 90 triangle, where we know the side opposite the short angle is 1/2, the side opposite the large angle is 3 pi or root 3 over 2. And so we can continue to fill out all of those coordinates of those points on that circle of radius 1 in the plane. I do want to go ahead and remind you that we don't necessarily have to stop with one rotation. We can go all the way around 2 full pi and continue to go another pi over 3, or we could even continue to go a pi over 6, and we're still going to be able to find the cosine and the sine based on the coordinates of the points in the plane that we get mapped to by taking that terminal side of that angle all the way around one full rotation and continuing to rotate it. So for instance, if I needed to find the cosine of 7 pi over 3, that's going to be equivalent to the cosine of pi over 3 because it's the same point in the plane. That would be 1/2, and the sine of 7 pi over 3 would be equivalent to the sine of pi over 3, which is root 3 over 2. So we can just continue to go. We can additionally talk about negative angle measures. This would be equivalent to an angle measure of negative pi over 6. So if I needed the cosine of negative pi over 6, that takes me right here to this point in the plane, and I know that that is positive root 3 over 2, where the sine of negative pi over 6, and I imagine we should probably put parentheses around those, would be the y-coordinate, and that would be negative 1/2. So there we've done all of our exact value measures in the plane using coordinate geometry, using the special right triangles that we learned in geometry. And so now we'll be able to come in on the next lesson and completely fill out the unit circle with no problem whatsoever using those relationships. So come to class next time and we'll work some homework problems over 30, 60, 90 triangles and exact values in the plane.